I want to find the distance between A and B. How would I do this? Subtract them. Is there a particular order you want to use, Dylan? Okay, sure. So maybe for the purpose of this, we'll assume that B is larger than A, and we'll say that we want to do B minus A. Now, Dylan, why was it important that we're subtracting the larger one minus the smaller one? What kind of result does that get us versus if we did it the other way? It gives us a positive number. So one thing to note here, when we are talking about distance, the thing that we are talking about is always going to be a positive number. So Dylan says here, one way to guarantee that we will make sure that we always have a positive number, let's make sure that we are doing larger number minus smaller number. I made the assumption here that B is going to be larger than A. Conventionally, with how number lines are set up, that is going to be true. What if, though, I don't know which one is going to be larger? What if I don't know whether B is larger than A or A is larger than B? Do I have a way of still ensuring that what I am looking at is positive? How could I do that? No ideas? How can we make a number always be positive? Absolute value, I think, is a really, really good idea for this. All right. So taking the absolute value of B minus A, and now all of a sudden it doesn't matter which one is larger. A could be larger than B, and as long as we take its absolute value, we are going to get the correct distance here. Now, absolute value is fine. The unfortunate thing about absolute value is the formulas for it can get a little bit messy. In particular, absolute value is actually a piecewise function, and I would actually rather not deal with a piecewise function if we can avoid it. So absolute value is really good. Absolute value is great, but I can actually get to absolute value through a slightly cleaner way. So taking the absolute value is a fantastic and absolutely correct way to guarantee that I get the number that I'm looking for, get the right distance. But what's another way that I could guarantee that this B minus A thing is always going to be positive? What else could I do to it? What else have we done to numbers that forces them to be positive? Yeah, we could square it. So we could take B minus A here, and we can square it. What is the problem that we run into when we square this distance? For instance, why would I say an absolute value is probably a little bit better in this particular case than just going ahead and squaring it? The distance changes. If this isn't a distance of 1, we're going to get a different numeric value. If our distance is 4, all of a sudden we're looking at 16. If our distance is 17.3, we're going to get some really, really gross, irrational number that lives somewhere between 4 and 5. All right. And so the fact that we have squared our value here, that we are looking at an adjusted value for the difference, for the distance, is a little bit of the problem, but we can be happy at the very least that our number is definitely going to be positive. So we have our positive number. Can we readjust this number to make it so that we haven't really messed with the size of the number at all? Okay, we could square it and then afterwards take the square root of our number. And that will rescale us down to the correct size that we want to be. If I take the square root of a number squared, then I will end up with a positive number that is the same size as the number that I am looking at. All right. So notice here, it's almost like the square root and the squared are going to cancel each other, but they always are going to leave something that's positive. And this is actually another way to write absolute value. What we have here is a slightly weird way, but a very, very powerful way to think about the absolute value between 2 points, between A and B. Awesome. This is one-dimensional distance. What I mean by one-dimensional distance, if my number line, if I'm only working with one number line where I can only move to the left or to the right, then I am working in one dimension. We're going to scale this up to 2 dimensions where I can move both to the left and right and also up and down. Right? In other words, we're going to look at what happens when we consider this exact same idea, but rather than on a number line, on our XY coordinate plane. Okay, so let's say we have 2 points here. We'll call this point x1, y1, and we'll call this point over here, we'll say that this is x2, y2, and I want to take the distance, here between these 2 points. Okay. Certainly a little bit of a trickier question. Definitely not as obvious how we would approach this kind of distance as directly as we were able to last time. So last time we had this kind of very clear notion of we're going to take the absolute value. Can't really take the absolute value in a conventional sense of like the difference between 2 points. Just doesn't quite work out the same. So we're going to need to be a little bit clever here with how we construct this. But with a slightly clever geometric construction, what we are going to get is a really, really nice simplified problem. So rather than tackling this 2-dimensional case as its own thing, let's try to see if we can break this down into a couple of 1-dimensional cases instead. To that end, I am going to think about a third point that is not on this distance at all. It is going to share an x value with my second point here. So it's x2, and it is going to share a y value with my initial point y1. And what I create with these 3 points is a triangle. Okay. Not just any triangle, though. What can I say about this triangle? It's a right triangle, right? Notice that our base is parallel with the x-axis. Notice that our height is parallel with the y-axis. And so what we get here is a right triangle. Awesome. Okay, we have the right triangle. I am looking for this distance, which is now turned into the hypotenuse of a right triangle. What formula do we have, or what theorem can we use to help us find this distance now? Pythagoras' theorem, the Pythagorean theorem here, where our distance squared is going to be equal to our base squared plus our height squared. Okay, so now I just need to figure out what A and B are. What are our base length? What is our height length? And this is actually pretty straightforward. We are traveling in a completely horizontal line. The only thing that is changing is our x. This is a one-dimensional distance. If I ask you for the distance between my initial kind of corner point down here and its compatriot over here, that is just the distance in the x direction between my 2 starting points. In other words, we can say that A is equal to, well, it could be the absolute value of the difference between x1 and x2, but let's write it as our new formula. We're going to say that this is the square root of x1 minus x2 squared. Does it matter what order I write x1 and x2? No. This distance is the exact same. We're taking the absolute value. Order here doesn't matter. If you want to write x2 minus x1, that's totally fine. We don't care. It doesn't matter. All right. If A is our x distance, what is B going to be? Our y distance. This is going to be the square root of, again, this one-dimensional distance. This is y1 minus y2 squared, taking the square root of that. Okay, so now we have all the pieces we need. Now we can kind of come together and figure out what is this final piece? What is this distance actually going to be? Notice here how I have a square root for both of my pieces. Notice also that I am squaring both of those pieces. What's going to happen with my square root when I square it? It's going to go away. It's going to disappear. Fantastic. And so we end up with the fact that d squared is equal to our a squared here, which is x1 minus x2 squared, plus our b squared, which is y1 minus y2 squared. This is really good. We could stop here. Are we looking for a distance squared, though? When we're asking about the length, when we're asking about the distance, we don't really care about the distance squared. We care a little bit more about the distance. So just to tidy this up a little bit, let's maybe say that the distance is the square root of everything that we're looking at. Now, normally when I take a square root, what do I have to be worried about? Negative, so like plus or minus on the outside. But what am I going to do with the negative possibility? Well, in terms, okay, so what I mean by here, what do I need to worry about? I guess it's a little bit of a vague question. In terms of inputs, I would need to worry about negatives. Notice that what we have here and what we have here are always going to be positive. They're just always positive numbers. But when I am taking the square root across an equal sign, I don't just end up with a square root on the other side. What else do I end up with? A plus or minus square root. In this case of x1 minus x2 squared plus y1 minus y2 squared. But since I'm looking for a distance, what do? I'm just going to throw away all the negatives. We know that this is going to be positive because we're looking at a distance. Okay, and what we have here is essentially absolute value for 2 dimensions. Right? We can now find the distance between points, not along a number line, but instead, not just along a number line, but now instead in 2 dimensions here. So this is where we are going to start. This is our distance formula, that d is equal to the square root of x1 minus x2, but again, the order doesn't matter, and then y1 minus y2, but again, the order doesn't matter. All right, questions here with our distance formula? Okay, let's take a look at example 1. We're trying to use our distance formula in order to figure out the distance between 2 points, how far apart they are. Again, order doesn't matter, so you can find the distance, you can find that change of x any way you want. You're going to square it, it's going to become positive. We don't care, it doesn't matter. Right? In this case, our distance is going to be equal to the square root of, we've got x1 minus x2, I'll write that as 2 minus -1 squared, plus y1 minus y2, we'll call that -3 minus 5 squared. All right. This is the same as, well, 2 minus -1 is going to be 3 squared, and -3 minus 5, -8 squared, where 3 squared is 9, and -8 squared is positive 64. Notice we got all positives. That was kind of our goal with this distance. Okay. Possibility for a pitfall. There is temptation here to split apart this sum, take the square root of 3 and add it to the square root of 64 and say that the final answer is 11. And what you have just done is equivalent to taking a plus b over a plus c and canceling these a's. You're not allowed to do that, right? You can't break things out of radicals over addition. You could do it over multiplication. You can't do it over addition. We have to actually add what we see here. And 9 plus 64 is going to give us something that is definitely not 11 squared. It gives us the square root of 73. Which, even if we could simplify it, I would not require us to, but 73 is in fact a prime number, and so we definitely cannot simplify it. This is our final answer. All right, questions here with example 1. All right. Now, I don't know why the sequencing is as pervasive as it is. This has also showed up in other curriculums that I've used, other curricula that I've used that teach the distance formula and circle formula kind of in tandem, which is a really wonderful way to derive the circle formula. It's, I think, quite cool. But they always, for whatever reason, between the distance formula and the circle formula, just throw in the midpoint formula, which has nothing to do with distance and has nothing to do with circles. I guess everyone is just really excited for you to know about midpoints. We'll cover it. It is not really something that I want to focus on, and I am moderately unhappy that I am having to take a detour from what is otherwise a really cool proof to talk about it, but it's quick. It won't take long at all. Let's assume here, rather than talking about the distance, we instead wanted to know the location of the point that falls right in between our 2 points here, x1 y1 and x2, y2. How could we go about doing this? The answer is actually fairly straightforward. We want to know the middle. We want to know in between these 2 points. And so we want to know the x value that falls in between those 2 x values. And we want to couple that with the y value that falls in between those 2 y values. In other words, we are taking an average of the x values and an average of the y values. It's really quite straightforward. How do I take an average? So for instance, if I gave you 2 test scores, if you scored an 85 on your first test and a 70 on your second test, how would you find your overall score? Fantastic. So we do 85 plus 70 divided by 2. If I were to give more and more tests, you would see that this divided by 2 at the third test would become a divided by 3. At the fourth test, it would become a divided by 4, so on. In this case, we're just focusing on 2 x values and 2 y values. And so the way that we compute the average of those 2 x values, we take x1 plus x2 divided by 2 and y1 plus y2 divided by 2. Addition doesn't care about order, so again, you can do this in whatever order you like. Yes, you absolutely can use this as a formula. I think a lot of the times midpoint problems are easy enough that you really don't need a formula to do them. For instance, looking at example 2a here, trying to find the midpoint between these 2 points, what is the value that sits perfectly in the middle of -2 and -6? -4. And what is the value that sits perfectly in the middle of -8 and -2? -5. And that's the midpoint. Okay, but maybe that's a little bit tricky to see. And so we could certainly use our midpoint formula here. We could certainly do -2 plus -4 divided by 2. And we certainly could do not plus -4, -6 divided by 2 to get -4. And we certainly could do -8 plus -2 divided by 2 to get -5. And that would work. But also, it's kind of a slightly more intuitive. Perfectly in the middle of -2 and -6 is -4. I'd say B is maybe a little bit trickier. This is where having the formula might be pretty helpful. Finding that y value that exists perfectly in the middle of 7/15 and -4/15 can be a little bit tricky. I think it's doable, but definitely potentially a little tricky. As far as x values are concerned, the x value that lives perfectly in the middle of -2/5 and -2/5. -2/5, -2/5. You could confirm that by doing -2/5 plus -2/5 divided by 2, and you would in fact get -2/5, right? If I add a number with itself and then divide it by 2, I'm just right back to where I started. Y value, again, a little bit trickier, but you could do 7/15 plus -4/15 all divided by 2. And you can simplify this a little bit. In fact, you would want to simplify this a little bit. You'd get -2/5. And I get 1/10 here, which is a little bit tricky, but overall not too bad. Seven minus 4 is 3. 3/15 is 1/5. 1/5 divided by 2, multiplying that 2 into the denominator is 1/10. Okay, so a little bit of a detour from really what is interesting and important from this particular lesson, but that's fine. We will recenter ourselves. Okay, so we just got our distance formula. And what I now want us to do is I want us to consider a circle. And we're going to say, for the sake of argument, that our circle is centered at the origin. So we'll say that we are centered at 0, 0. And I will do my best to draw a competent circle. We will see how well I do. Off to a rousing start. Okay, I think that's my worst one of the day, but you know what? That's fine. Okay, we draw our circle. We're slightly disappointed in it, but that's okay. And I want to ask the question, if we are thinking of the center of our circle up to the edge of our circle, we'll call this point on the edge of our circle x1, y1. And I want to know the distance between these 2 points. How could I find it? We could definitely use the distance formula. So this is going to be the square root of x1 minus 0 squared plus y1 minus 0 squared. Okay. A little bit funky there. I'll clean that up. Actually, here, we'll do this. Of y1 minus 0 squared. But what is this the same as? Okay, so we could simplify it to become x1 squared minus y1 squared. That is certainly true. But what did I just describe? What feature of the circle did I just describe? The distance from its center to its edge. That's the radius of our circle. So this distance that we just calculated should be the same as our, again, I'm going to adjust here for space. I'm going to adjust here for space. This should be the same as our radius. And in fact, if I ask the question, what is the distance to maybe the second point, x2, y2, and our center, what is that distance? Say again? Yeah, well, not r squared. It's going to be the distance from the center to the edge. Yeah, they're both r. Yeah, this is the same distance, all right? And in fact, it doesn't matter where I pick on my circle. I could pick any random point here, and as long as I'm on my circle, that distance r is always going to be fixed. Okay. So let's let x and y be some generic point on our circle. So instead of a specific x1, y1, we're looking at the generic x and y, which are just all possible points on our circle. The way we actually define points on a circle in kind of a more algebraic sense is think of a circle itself as the set of all ordered pairs that are a fixed distance away from the center. Right, so they are all a distance of r away from a particular point. That's how you generate kind of that entire circle. But to that end, what we can say is that r should be equal to the square root of x minus 0 squared plus y minus 0 squared. All right, so rather than like a specific point, we're saying, well, really, this distance works for all of the points that live on our circle. They are all going to be a distance of r away from our center. Awesome. Now, we used a specific center, 0, 0. What if I wanted to change that specific center to a generic h, k? What would I be replacing? Yeah, I'd be replacing the zeros. Instead of x minus 0, what will I have? X minus h. And instead of y minus 0, what am I going to have? Y minus k. Fantastic. And that is our circle formula. Well, okay, that's our circle formula. This is totally fine. I think this formula does a really good job of kind of highlighting that it comes from the distance formula. But more often than not, the way that you're going to see this written is that r squared is equal to x minus h squared plus y minus k squared, which like is fine. It's serviceable. It does its job. But I like the connection to the distance formula a little bit more, but more often than not, I would say you're going to see it like this. Okay, so we could think of our circle formula. Again, this is our r squared equal to x minus h squared plus y minus k squared. All right, let's take a look at example 3. Example 3 asks us to give the center and the radius of the circles that we are looking at. It also asks us to define the domain and range. Normally, this is kind of a big headache, is looking at domains and ranges. It's actually not horrible with circles. Notice that the maximum x value is going to be achieved when we start at the center and follow kind of this distance of r to the right. And we get the minimum x value by starting at the center and shifting by r to the left. Likewise, we get the maximum height by shifting up by r from the center, and the minimum height by shifting down by r from the center. And so really the range and domain is very doable here. Okay, looking at 3a, let's just go ahead and go through these. What is the center of this circle going to be? -3, 4, very good. Remembering that because it's minus h and minus k up here, that we reverse the signs of the x coordinate and the y coordinate, right? So the minus h minus k means we flip the sign, so we get -3 and +4. What is our radius? 4 is related to our radius. What is 4? It's the radius squared, and so our radius is going to be 2. So we take the square root of 4, which gives us 2. Okay. If we're thinking about our domain, I want to know the minimum value of our domain. So if I'm centered at -3, 4, and I travel a distance of the radius to the left of my center, what x value am I going to end up at? -5, fantastic. And if I start at my center, -3, 4, travel the distance of the radius to the right, where am I going to end up? Remember, domain is going to be x value. So thinking starting from that x value, traveling to the right. Not quite 2. What's our starting x value? Where are we starting from? -3. If I travel 2 to the right, I end up at -1. What's our starting x value? -3. If I travel 2 to the left, where do I end up? Yep. And for our range, where's my starting y value? Starting from 4, very good. And if I travel 2 to the left, I'm going to end up at 2. And if I travel 2 to the right, I'm going to end up at 6. Very good. Should we try another? Okay. Let's look at B here. What is our center going to be? 0, +2. Very good. Remembering both that there is still an x-coordinate there. We're subtracting nothing, so subtracting 0, and also flipping that -2 to a +2. What is our radius going to be? 4. So taking the square root of 16 to get 4. What is our domain going to be? What's the minimum value of our domain going to be? -4, and the maximum? +4. Okay. And then for our range, what's the minimum value going to be? -2, and the maximum value? +6. Very good. All right, questions here with distance formula, with circles, midpoint. Yeah, Dylan. 1C. Yeah. So we could take a look at this. Distance formula here, this is going to be that the distance is equal to the square root of, in parentheses here, I'll say 0 minus √5 squared plus -√3 minus 0 squared, which is going to give me the square root of -√5 squared plus -√3 squared. -√5 squared is just what? 5. -√3 squared is 3. And so I end up with the square root of 5 plus 3, or the square root of 8. Which is as simplified as I need you to make it. That's totally fine. Pearson might have other words. Sorry, can't really change that. But it's as simplified as I need it to be. Any other questions that we'd like to go over? All right. Unit 1 study guide has been posted to Schoology. You should be able to take, I think I put a limit of like 20 times on there, but also you can review the study guide each time. So should be relatively workable. I will say I will post, and I mentioned this on Schoology as well, I will post an answer key, kind of my going over each of the questions to Schoology sometime on Sunday, probably a little bit later on Sunday. There is, if you go onto Schoology now in the Unit 1 folder, there is a link called the 824 exit ticket. If you guys would just take 5-10 minutes to go through that. A lot of what that is what would you like to see tomorrow for the review? What questions would you like to go over? Things like that. So I'll try to kind of model what we do for the review off of that. And then in addition to that, just kind of also gives you some ideas maybe about study resources that you can use, things of that nature. We have about 30 minutes left. If you guys would take the rest of this time, work through that 1.6 through 1.9 classwork, or through the Unit 1 study guide, both of those would be really good resources to get you ready for the test that we have on Monday.